All right, so let's get started. So welcome everyone to the winter school on blockchains. Thank you so much to the organizers for organizing this. This is like a wonderful, wonderful, wonderful event. I have to tell you, it was really difficult to prepare all the lectures because we just have too much to say. Yeah, there was so much that we wanted to share with you that the hardest thing was actually packing everything into the allotted time. And I'm going to say more about that actually in just a minute. I'd like to say actually before we get started that the reason we do this in person is so that everybody can ask questions. So please, if there's a question that pops into mind, go ahead and interrupt the speaker and ask your question. I think all the speakers are very well versed in dealing with questions as we speak. So this will be helpful for everyone. So with that, actually, let's get started. So So cryptography, as you know, has a lot of application areas. But traditionally, the application area that cryptography kind of shown in was primarily used for was for internet security, right? How do we make sure that when you send your credit card over to the other side, the credit card actually gets there securely and nobody can steal it? So on the internet, cryptography mostly is being used by and large for encryption, key exchange, mostly for sort of confidentiality applications. What's interesting is in the last couple of years, all of a sudden there's a new customer for cryptography. You all know who the new customer is, and the new customer, of course, are these blockchains. And so there are kind of two important differences between applications of cryptography and blockchains and on the internet by and large. First of all, on the blockchain, the focus is not so much on confidentiality, even though I should say that is changing because of MEV, which is something that we'll talk about on the last day. But primarily, the focus of cryptography on the blockchain has to do more with data integrity. And so you can see that the primitives that cryptography is being used for on blockchains are things like signatures, commitments, zero-knowledge proofs. Those are all data integrity style mechanisms. In particular, I guess I should have written here proof systems, but in general, the focus is on data integrity, not so much on confidentiality. And of course, threshold signatures all of a sudden are now critically important. There are lots of open problems around threshold signatures that we'll talk about during the school. I should say, by the way, that this new customer, raises a ton of new open problems in cryptography for all of us to work on. Yeah, so we are going to try and cover many open problems during the day today and during the school overall. We're not going to be able to get to all the open problems, so I think it is very good for everyone to kind of grab the speakers and kind of ask them, what's your favorite open problem that's motivated by blockchains? And there's a lot more work to be done here. So yeah, so this will come out during our 4 days. Now I should say my first lecture is just meant to sort of introduce everybody to the blockchain space. I think all of us, as we prepared the material, we assumed that the audience is primarily cryptographers who want to get into the blockchain space. And so there's a lot of background material on blockchains. Today overall is going to be an introduction to blockchain sequence of lectures. And so this particular lecture is going to be a little bit high level, and then we'll get into the technical details right after. All right. So let me kind of jump ahead and say that basically that there's this new field that's emerging, which we like to call the science of blockchains. Yeah, so science of blockchains is, I would say, quite different from blockchains which you hear about in the press, right? The press, if all you know about blockchains is what you read in the press, then you know nothing about blockchains. You should really forget everything you read and start from scratch. Yeah, so the science of blockchains is a very different area that focuses on the technology that underlies blockchains. And I have to say, it's really quite an incredible area to work in, just because these blockchains are a major driver for lots of new technology, right? So as we've seen, there are lots of new consensus protocols. The whole area of consensus was revived because of blockchains. There are a lot of new cryptography applications. We'll talk tomorrow about all the developments in the area of snarks that's been driven by blockchains, and you'll see it's quite remarkable what's been happening. There's a lot of work on economic models, a lot of work on governance, which is kind of remarkable. All of a sudden, I find myself collaborating with folks in political science because political scientists are experts in governance. And so all of a sudden, there's like interaction between computer science and political science just because of blockchains. Obviously, the programming languages and verification folks are quite excited because when you're writing short programs that manage billions of dollars, it's kind of important to get those programs correct. They need to be right. And so all of a sudden there's a revival in verification tools for blockchain. So it's kind of remarkable how the blockchain space it's driving this whole scientific development. So in that sense, it's a really exciting area to work in. There's collaboration across computer science and beyond. As I said, I find myself collaborating with political scientists, with lawyers, with economists. So again, things that would have not happened without this area. So just to coin the term, science of blockchains. So science of blockchain now became actually a term of art, and there's even a conference called the Science of Blockchain Conference. It's an annual conference. We're running for 6 or 7 years now, and the next one is in August 2023. You're all welcome to come and see kind of the latest and greatest research in the science of blockchains. Okay, so now that we've said that, I guess if you have to ask me, if I have to kind of summarize, what is this? What are blockchains for? What are blockchains? What are they good for? If I have to summarize it in one sentence, I would say that basically blockchains are basically a way, it's a way for a large set of parties to collaborate and coordinate with one another when there's no single trusted party that they all trust. Yeah, that's the purpose of a blockchain. Just large-scale collaboration without trusting any single party. The contrapositive of that, you realize, is if you do have a trusted party, like say the government or let's say Google or whoever, if there is a trusted party, you don't need a blockchain. Yeah, and I want you to remember this is a very important contrapositive to the definition because often you hear various scientists even would say, especially in certain areas like in healthcare and so on, they would say, we have a bunch of data, why don't we store it on a blockchain just for the heck of it, right? But in those environments, usually there is a trusted party, and so a blockchain is likely not the right solution for you. Yeah, there are cases where there is no trusted party, where it's a perfect fit, but it's not always a perfect fit. So I want you to remember this. It's not the case if you have data, it belongs on a blockchain. That's just not true. In the world of finance, of course, everybody's out there for themselves, so it's not surprising that there's such a good fit between blockchains and the world of finance. All right, so blockchains have found a number of application areas. There are 3 that I want to talk about, and hopefully more application areas will come in the future, but these are application areas that are already currently working and drive quite a lot of activity. So of course, everybody knows about the application of blockchains to finance. We're going to talk about DeFi later on in the day today. There'll be an entire lecture just on that. The point of DeFi is sort of enabling new financial instruments like exchanges, lending, and I'll say more about that in a second. The other area is basically this area of managing digital assets. Digital asset ownership belongs very naturally on a blockchain. Once it's recorded there, no one can take away the asset from you. I don't like to say the word NFTs because if I say NFTs, you guys are going to start thinking about apes. And so I don't want you to think about apes, so I just like to call it managing digital assets. Yeah? You basically have guaranteed that the provenance of the asset, where the asset came from, and so on. And the third area is what are called DAOs, decentralized organizations. I'm going to talk more about DAOs actually in just a minute, but this is basically a group of people who want to come together and manage resources together, manage assets together, maybe for donations, maybe for collecting art and so on. And so this is exactly where governance comes in, where you need mechanisms to enable a group of people who are not trusting one another but still want to collaborate. How do you enable them to do decisions? And again, as I said, I'll talk about that a little bit later. Now, I want to show you a graph that I really like, which kind of says where all the activity in the blockchain space is. And the way we measure activity is actually by where the developers are. Yeah, where are all the developers focusing their effort? And so there's this very nice graph that was generated by the Electric Capital that tracks Git commits to various blockchain projects. And what's interesting, you can see the x-axis is basically how old the project is. So of course, Bitcoin is the oldest project. And then the y-axis is how many developers are actually actively committing. These are like full-time developers. So they commit like, I forget, they do 10 commits a week or so. So this is like, effectively, these are like the number of full-time developers. Overall, there's like over 20,000 developers now in the space. So it's a big attraction for actual people writing code. What's interesting is you notice that all of the activity, developer activity, is focused on the Ethereum space. That's where the bulk of the developers are. not so much on Bitcoin, which is why actually most of our crypto school is actually going to be focused on Ethereum. Yeah, so this I want you to understand why we are focusing so much on it, so much on Ethereum. You can see the up and coming ecosystems. Cosmos has a lot of developers, Polkadot has a lot of developers, and so on and so forth. Yeah, and then basically there's a bunch of other smaller ones. But the reason I like this graph is it explains very clearly why is it that we focus on Ethereum so much, and basically this is kind of where all the action is. Okay, so in this course, we broke it up into 4 different topics. I guess I'll go through this quickly because you guys already reviewed it. This today is basically going to be an introduction just to make sure everybody's on the same page. For those of you who are already familiar with blockchains, maybe feel free to jump in, by the way, if there are things you'd like to expand on. But this is primarily just this day is just to make sure everybody's on the same page. We're going to talk about proof systems tomorrow. It's remarkable to see how, in some sense, proof systems are now a critical enabling technology for blockchains. Yeah, the space cannot continue to develop without good proof systems. So it's really quite remarkable to see how prevalent they are and how much is advanced. Then we're going to talk about consensus protocols, and finally we'll talk about kind of DeFi and user-facing tools. Now, the one thing I would say is, as I said, it was really hard to prepare all this material because there's a lot to say here. And in fact, for the organizers, keep in mind that literally each one of these days could be an entire crypto school. So maybe ideas for future crypto schools. Okay. So with that, let's start at the beginning. Yeah, so let's kind of talk about the basics of blockchains and go from there. So blockchains, of course, as you know, started in 2009 with Bitcoin. But what I'd like to always present is basically what is the new technology, what is the new capability that Bitcoin gave us that we didn't have before? Yeah, most people would say, oh, it gave us the Bitcoin currency. But no, that is actually not what Bitcoin provided us. And so just, again, to make sure everybody's on the same page here, what Bitcoin gave us is a fundamental capability that we didn't have before. What is that capability? Well, it actually gave us what's called a ledger. Yeah, it gave us a database, which is a public append-only data structure. Yeah, so anyone in the world can write to this data structure, and once you write something to this data structure, the data can never be removed. Yeah, that's the fundamental new capability that we did not have before, right? An append-only data structure that anyone can write to, and then the data can never be removed. The reason that's so useful for finance is because if I pay you, it's really important that once I write this transaction to the blockchain, to this data structure, no one can remove it from the data structure so that I cannot withdraw my transaction, and my payment will always be written there, so it's always recorded that I actually paid you. So this is why it enabled, a digital payment system, Bitcoin. Bitcoin also came with a fixed supply asset. But the main thing I want you to remember is it gave us kind of a public append-only data structure. That's kind of the main point of Bitcoin. The next development, I mean, there have been many developments, but the next big development is Ethereum. Ethereum basically gave us a fully programmable environment, which we're going to talk about later today, when we can actually run programs, and these programs on the blockchain. These programs manage digital assets, and again, we'll see exactly how that works later today. The other very smart design choice that Ethereum made is it made these programs composable. Yeah, so if I write a program and I want to call somebody else's program, that's actually quite easy to do. And so these programs can transfer assets between one another. And again, we're going to see that later in the day. Everything okay? Okay, cool. All right. Good. And of course, once Ethereum came out, we saw the growth of the application areas that we talked about. And of course, now this ecosystem is actually quite large and thriving. All right. So I like to think of a blockchain, this is a little bit basic, but I do want to make sure everybody's kind of on the same page. So I like to think of a blockchain as 4 different layers. At the bottom layer, there's what's called the consensus layer with data and the data availability layer, which we're going to hear about in the next lecture. Above that layer is what we call the execution layer, right? This is where the programs actually run. And we're going to talk about the execution layer in the first talk after lunch. Once we have programs that run on a blockchain, basically people can write applications that run on top of this computer. These are sometimes called decentralized apps, So dApps, sometimes they're called smart contracts. I'm going to use the term dApp. Actually, I'm going to use both terms, dApps and smart contracts interchangeably. But just think of these are applications that run on top of a blockchain. And finally, we have a lot of user-facing tools like wallets, cloud servers, and such that people actually use to interact with the chain. Yeah, so these are kind of the 4 layers of a blockchain. I think it's good to think about it in those terms. The consensus layer, I'm not going to say much about here. Lara is going to talk about that at length in the next lecture. I'll just say the goal of the consensus layer is to build this public data structure, right? The way we build a public append-only data structure. Actually, maybe I should back up just one second. Building a public append-only data structure is actually quite difficult. The reason, so again, everybody can write to this data structure, and once something is written to it, the data should never be able, you should never be able to remove that data. Yeah, that's actually quite difficult in the real world because computers can always be rewound, right? You can always rewind the state of your computer, reinstall the operating system, and rewind it to an earlier state. So how do we prevent data from being deleted from a blockchain? And the answer is we prevent it by replicating it all over the world, right? So fundamentally, the way we ensure that it's a write-only append-only data structure is by replication. The minute you start replicating data over the world, you have a consensus problem, right? What if one replica is different from another replica? And so if I send a transaction to you, maybe one replica says that I had the transaction, another replica doesn't say that I have the transaction. How do we make sure that all these replicas are in sync with one another? And that's exactly the consensus problem. Yeah, so often we call this safety. Safety means that in fact all the replicas of the data structure have the same data. Again, this is a very informal definition. Lara will give a more precise definition. There's a little caveat here, which I'm not going to get into. Well, maybe the caveat is same maybe except for the last couple of transactions. And this basically is what ensures persistence, that the data can never be removed once it's added. The other property is what's called liveness, of course, that no one can prevent you from posting transactions to the blockchain. So it's impossible to censor someone, right? So if I pay you, if you could not spend your funds, if you could not issue transactions, it doesn't matter that I paid you. The funds are not available to you. Yeah, so it's very important that no one can prevent you from posting transactions to the blockchain, and that's the liveness property. And so these two together basically make up a consensus protocol, and again, we're going to see that in the next lecture. Once we have a consensus layer, we can build a blockchain computer on top of it. This computer, as we said, basically maintains the state of the chain. Yeah, so it maintains a lot of data. Everything that's written to it can never be removed. It always stays there. It can only grow, and that's kind of the on-chain state. This computer basically implements, as we'll see, it implements a virtual machine that can run programs, and then people can write applications on top of this virtual machine. As I said, these are the distributed applications. What's interesting about these is this effectively the code of the applications is written to the chain. All the state of the application is written to the chain. Yeah, so effectively the code is replicated all over the world. The current state of the program is replicated all over the world. And the beauty of it is that anyone can submit a transaction to any of these programs. These transactions basically cause these programs to change their state, and then the state updates are again replicated all over the world, and no one can undo a state transition. Yeah, so once a program decides to accept a particular transaction and act on it, no one can revert that transaction. All they can do is they can issue more transactions. Yeah, so this is how programs run on the blockchain. Again, we'll see that in much greater detail later this afternoon. And finally, the top layer is what I would say is how the users actually interact with these programs. Typically, they interact through the cloud, just what we would call the Web 2 traditional cloud. Yeah, so there would be regular websites that users could interact with. These websites would interact with the chain itself, and then the end user interacts with the cloud. One thing that's interesting is, by the way, the cloud typically will maintain a copy of all the states. So all the states changes, the current state will be written to the cloud. The difference between this and Web 2 is that the entire state is actually written on chain, of course. And if those two things go out of sync, the Web 2 infrastructure is inconsistent with the Web 3 infrastructure, the ground truth is actually Web 3. Yeah, what's written on the blockchain is what the truth is. This is just a backup copy that's meant for performance reasons. It doesn't actually hold. It doesn't actually represent the real truth. Now, what's interesting is, of course, as you know, this has grown tremendously. So a lot of projects have deployed these decentralized applications. These applications, they're not that big actually. These applications are maybe like 1,000 lines of code, maybe 2,000 lines of code. They're not very big. And what's remarkable is that these applications that just run on the chain like this, now these days, they actually manage billions of dollars, right? So, MakerDAO, it's a couple of thousand lines of code, manages $7 billion. I wrote down a couple of the big applications. It's really quite remarkable to see, programs that all of us can actually read and analyze and see exactly how they work. And these programs actually manage very large sums of money. And again, this is quite different from how the world of finance works today, where most of the world of finance is a black box to us, right? We have no idea what the Wall Street companies are doing. We trust that they're doing things okay because they're regulated by the SEC and other government organizations, but we don't really know, right? They could have all sorts of back offices and back deals. Here, the code is completely available in the clear. Anyone can inspect the code. Anyone can inspect the state of the application, and you can see, then choose whether you want to interact with it or not, or maybe you can trust other people to inspect the code and tell you whether you should interact with it or not. Yeah, so kind of everything, the transparency is supposed to be, is actually a big motivator here. All right, so that's a quick overview. Remember I said there were 3 application areas, right, primarily. It's basically DeFi, managing digital assets, and DAOs, decentralized organizations. 3 application areas. What I want to talk about now a little bit is about these 3 areas. I'll only talk about, so I'm going to leave it to Arthur to talk about DeFi, although I'll say a few words about DeFi. And then I want to spend the rest of my time talking about decentralized organizations, because we're not going to talk about them any other time in the course, and in the school, and there's actually lots of open problems around DAOs as well. So I want to tell you about those open problems. But let me start with DeFi. So again, the point is, if you want to deploy a financial instrument of any kind, you are free to write an application, deploy it on chain, and run it. This is very different from the traditional financial world. Just think about this. If you want to deploy an application on, an existing bank's infrastructure, and your application might compete with one of the services that the bank currently offers, good luck deploying your application on the bank's infrastructure. Yeah, so it's very difficult to deploy new applications on the current financial infrastructure. In a blockchain, nobody can prevent you from deploying new applications, right? So if you have a new idea for something you want to experiment with, no one can stop you from deploying the code. Anyone can inspect the code and verify exactly what it does. Yeah, it's transparent. Anyone can inspect the code. And what's amazing also and very, very powerful is this composability property where dApps can call one another. In particular, for those of you who have not seen this, there's a very successful standard. This is probably one of the most successful standards in the blockchain space and even beyond. It's called the ERC20 standards, which is literally 6 functions. Yeah, if you implement those 6 functions in your code, you are ERC20 compliant, and then any application in that ecosystem that supports ERC20, that interact with ERC20 coins, can interact with your application. So this has been enormously powerful in the EVM world. That's just 6 functions basically open you up to interacting with kind of a world of DeFi. And again, Arthur is going to go into this in a bit more detail. So one question that I always get asked is, why do we need this? Like, why do we need DeFi? We have a perfectly fine financial infrastructure, right? So why do we need a new financial infrastructure? And so I want to point out 3 issues with the existing financial infrastructure that perhaps blockchains can help with. The first one is what's called cross-border inefficiency. And so I just encourage you to do an experiment. Suppose you live in South America, Brazil, Argentina, or whatever, and suppose there's an artist in Thailand that you really like, and you want to donate $10 to them. Yeah, from South America to Thailand. Yeah, that's a reasonable thing to try and do. If you try to use the existing infrastructure to do it, you're just sending $10 from one country to another. You're going to be hit with enormous transaction fees and transaction costs. And just try it out. You can go to any of the websites that will let you send funds from one country to another, South America to Thailand, as I said. You're going to have ridiculous transaction fees. Of course, in the blockchain space, this is really easy. All you have to do is just issue a transaction. The blockchain doesn't care where the transaction is coming from or where it's going to. The fees will always be the same. That's one. The other issue is, Some of us live in countries where we trust the financial system. I trust the US financial system for sure. But some of us live in countries that don't trust the financial system, just they don't have faith in it. And there's this beautiful article, I highly suggest reading it. It's a short article, go look it up. It's actually a very worthwhile article. It's written by an economist from Venezuela that explains how he uses crypto to basically protect his life in a failing financial system. Yeah. So in fact, we see this all over the world. People who live in with an unstable fiat currency, they have a lot of interest in DeFi and blockchains in general. And there are many articles like this. This is a particularly good one. So I really encourage you to go read it. That's the second argument for blockchains. And the third argument is actually, that if you happen to not have a lot of assets, banks generally don't want to deal with you, right? They will charge very, very high transaction fees or service fees in general if you happen to be poor, unfortunately. There's a statistic that even in the US, 5% of households are unbanked. And why is that? Most of it is because of the service fees that banks will charge you as a result. Well, again, the blockchain doesn't care. You can have a lot of assets or very few assets. Service fees are going to be the same. The blockchain just doesn't care. So this potentially could be another reason why DeFi would appeal. Of course, this, by the way, requires quite a lot of computer literacy. And so, it's not proven that this works, but again, I would say it's another argument for why DeFi is quite useful. Okay, so great. So given all that, I would say there are two ways to view DeFi. And I wanted to just to make sure this is out there. I'm not sure Arthur is going to get to it. So I just wanted to make sure this is out there. So there's a DeFi optimist who would say DeFi is a technology advance that enables easy access to the financial system. Anyone with an internet connection, it doesn't matter where you are in the world. As long as you have an internet connection, you can connect to the DeFi ecosystem, and basically as a result, you enable new capital efficiencies for yourself. That's the optimistic point of view. There's also another point of view. The other point of view is the pessimist, which says this is basically an unregulated, hack-prone system that enables novel forms of financial crime. And, I don't know which one is right. Well, that's kind of time will tell, right? It's up to you to decide, and maybe Arthur will talk about that more. But I do want to emphasize there are these, it's not all rosy and, all great. There are also obviously reasons for concern, but this is kind of where we are now, and, time will tell which of these is right. So that's all I wanted to say about DeFi. I'm going to leave the rest of it to Arthur to cover later today. I want to switch gears now and talk about DAOs. Okay, so DAOs are a really, really interesting area. There are lots of open cryptographic questions around DAOs, and so let's go dive in and see what they are. So actually, you know what? I think it would be really helpful, maybe even for the other speakers. Let's do a quick show of hands. How many of you have heard of DAOs before? Raise your hand if you've heard of DAO. Excellent. So you know the term. How many of you are members of a DAO? Nobody, basically, like 3. Wow. So nobody's joined the DAO. Okay, good. That's exactly, okay, so like 3 or 4 have actually joined the DAO. Good. So you're exactly the target audience. Fantastic. So I think this gives a sense to the rest of the speakers, right? People kind of have heard the terms, but haven't actually used the systems. Good. So let's walk through it. So what is a DAO? A DAO is basically, as I said, a decentralized application, a contract. It's deployed, let's say, on the Ethereum blockchain at a specific address. Yeah, so it's just a program running on a specific address on the Ethereum blockchain. Anyone can send funds to this DAO. So now the DAO manages its treasury. It's a program that manages the treasury, but it manages it in a very interesting way in that anyone in the world can submit a proposal to how to use the treasury. And then basically the members of the DAO will vote on the proposal. So really, it's a contract that runs, a program that runs on the Ethereum blockchain. It has a treasury. Anyone can submit proposals, and anyone can submit votes on proposals. And if the proposals are actually approved, the proposals go get executed. Yeah, so this is how a collection of people can together decide how to manage the DAO treasury. I think the closest thing in the real world to this is actually kind of a partnership. Yeah, partnership is a legal term. Partnerships, as you know, are quite complicated to set up everywhere in the world. They're quite complicated to set up. A partnership basically lets a bunch of people get together and manage a company or a treasury together. Here, basically, instead of here, it's I would say basically it could be an unregulated partnership. Here, effectively the partnership is managed by this program that's running on the blockchain. Good. I should say, actually, one more thing that I'd like to say here is actually the way the votes are done. The reason I wrote snapshot here is because the way the votes are done is in two possible ways. You can vote on-chain. In other words, if somebody submits a proposal, you can have people vote on-chain on the proposal, so they can submit their votes, and then if the proposal passes, it executes, otherwise it doesn't. That's actually quite expensive to do, right? Because every transaction that goes on-chain has transaction fees associated with it. So people would have to pay these transaction fees or have the DAO pay for them, but there's a cost involved with voting on-chain. So it's quite inefficient. As a result, or expensive rather, as a result, there's a tool called Snapshot, which basically allows voting to happen off-chain. Yeah, so everybody votes, the tallying is done off-chain, and then once the proposal either passes or doesn't pass, if it passes, there's a mechanism that moves the off-chain vote on-chain. Yeah, that actually is where there's a lot of concern, because that's a centralized point of failure. Right? So the tally happens, you have to move the result on-chain, and then the result executes. If the wrong result is moved on-chain, a proposal might get executed on even though it didn't pass. And so often what you see people do is they use Snapshot as a way to canvass the community very quickly, just to get a quick vote to see what people think of a proposal. And if the Snapshot says, yes, it passed, they'll do a vote on-chain to actually go and execute it securely. But keep in mind, there is this issue here. How do you do votes off-chain and then securely move the result on-chain? That's a question that there's a lot more work that's needed on that question. Good. So let's go over some examples of DAOs. So there are lots of DAOs out there. People have set up like 12,000 DAOs or so. There are DAOs that collect art. For example, Pleaser DAO, Flamingo DAO, Constitution DAO. These are DAOs, well, that collect various assets. For example, let's talk about Pleaser DAO. You can look at the gallery. Pleaser DAO likes to buy art. Yeah, so it's a collection of, they have 103 members. They have a treasury. And then they go and bid on art projects to buy those art projects, and they have a gallery that shows all the art projects that they actually bought. What's interesting, and I want you to keep this in mind, is Pleaser DAO actually has full-time employees. Now, who's the boss of these employees? Where are their salaries coming from? The boss and the salary is coming from the DAO program. Yeah, so this is a situation where your employer is a program. Right, it's a program running on chain. Your salary is paid by a program. And all the questions of, if you get sick, who pays your medical bills? Well, it's this program that has to pay your medical bills. Right, if you retire, who pays your pension? Well, it's this program that has to pay, right? So all of a sudden, you can see that kind of managing DAOs is kind of interesting. Your boss and your salary all come from this relatively short program that people can write proposals to. So then basically what they do is they discuss with one another. Often they discuss with one another on Telegram what to bid, what art they want to buy, and once they decide what to do, they go ahead and actually submit a proposal. They vote yes on the proposal, and the treasury gets spent to bid on the piece of art that they wanted to buy. Yeah, so that's one example of a DAO. Another example of a DAO is a DAO that issues grants. So Gitcoin is a very famous DAO. There's 83,000 members in that DAO. Again, it has a fairly large treasury, and what it does is it gives grants for people to develop open source software. It's a pretty cool goal. So if you have an idea for an open source software that you want to develop, you can write a proposal to the Gitcoin DAO, right? Submit your proposal on chain. The Gitcoin members will vote on that proposal, and if the proposal passes, they decide to fund your open source project. Gitcoin treasury will be allocated programmatically. The Gitcoin treasury will be allocated to you, parts of it, and you can go ahead and be paid to develop your open source project. Yes, it's a pretty cool way to fund open source development just by having people donate and then vote on proposals. So here, let me give you an example. Proposal ID 21, I don't know, they wanted to allocate 30,000 Gitcoins for a particular task. This is a marketing task. It doesn't matter where it is. Proposal ID number 21. Yeah, we want to allocate some funds to this particular task. Now, you can look at it on chain. You can look and see basically how people voted, and you can literally see the votes as they happen, Because remember, the chain does not keep any secrets. Everything is in the clear. Everybody can see how everybody voted. Everybody can see how the votes actually develop. And so you can see literally as people vote, here this line indicates how many people need to vote in order for the proposal to pass. And you can see at this point it passed, even though people still kept on voting. Not only that, you can see that the participation rate, about only 8% of the DAO members participated. And this is actually the biggest criticism on DAOs, is that participation rate in votes is relatively low. Now, we know this from world history, right? The DAO that I described today, right now, is what's called direct governance, right? Direct governance is where everybody votes on every proposal, right? This is what the Athenians back in ancient Greece used to do. Everybody had to vote on every proposal. We know that direct governance doesn't work because people are busy, right? They have other things to do other than vote on everybody's proposals. So direct governance actually results in very low participation. And so the question is what to do. What is the right way for a DAO to manage these votes? And I'll say more about that in a minute. But you see, basically, once the vote actually passed, you can see that it passed. It goes ahead and allocates the funds, and block number such and such on Ethereum goes. Yes. Oh yeah. Please. Yeah.
Are there DAOs that provide some form of privacy for users?
Excellent question. Hold that thought. That is the perfect question from a cryptographer, and so we're going to come back to that to talk about that in a second. That's exactly a wonderful area for open research, which I'll talk about in just a second. Great. Okay. So yeah, please keep it coming. If there are more questions, please ask. All right, so anyhow, you can see that a particular block number executed this transaction, and the funds were actually allocated for this task. So that's a grant DAO. There are also protocol DAOs that control basically how protocols operate. So there's a Uniswap DAO, there's a Compound DAO that people vote on changes to the protocol, and hopefully they don't approve harmful changes, and that's basically how protocol changes are done. And then there are many other DAOs. There are social DAOs, there are investment DAOs, and so on and so forth. Yes, there's a very large category of DAOs. So when it comes to governance, again, this is a huge area for open research problems. Huge area for open problems. How do you decide who votes in a DAO? How do you decide how to vote? Yeah. How do you decide what the voting mechanism is? Is it one person, one vote, or is it one token, one vote? Yeah. If you think about it for a minute, you'll see that one person, one vote doesn't work very well. Yeah, it kind of has to be one token, one vote, but maybe there are other mechanisms that can work. And so, yeah, there are lots and lots of questions here. If you're interested in these kind of governance questions, basically what are good governance mechanisms for DAOs, there's this beautiful article that Andrew Hole and Porter Smith wrote. It basically says, Andy Hall is a political scientist. He basically says, humanity has studied governance for 10,000 years. You guys don't have to start from scratch. You can learn a little bit from what humanity has learned. And so, why don't we just political science can inform DAOs in how to govern. And already you see DAOs are starting to adopt other governance mechanisms. For example, even the standard governance contracts, what's called governance alpha and governance beta, the standard governance contracts, they support delegation, right? So if I have a lot of governance tokens, I can delegate to a particular person that I trust to vote on my behalf, so I don't have to vote every time. Yeah. And what's interesting about this is it very quickly leads to what's called liquid democracy, where I can delegate my votes to someone and they can vote on my behalf, but if all of a sudden, I don't know, they turn out to vote badly, or maybe they turn out to be a bad person, I don't have to wait 4 years until the next election to remove my votes. I can immediately undelegate to them and delegate to somebody else. And if enough people do it, they're out of the system. They can no longer vote on our behalf. I think in Israel these days, this would be a pretty useful mechanism if it was if it was implemented. Yeah. So. So those are the governance contracts. That's examples of a governance contract where you can just kind of on the fly decide to delegate to other people if all of a sudden you don't like how they behaved. And by the way, we see this happening all the time. There are people who received delegations, and later those delegations are taken away from them. So the amazing thing about this is like a heaven for political scientists. Right? They can experiment, they can come up with all sorts of governance mechanisms. In the real world, you have to start a new country to see whether the governance mechanism works or not, Right here, you can just deploy a DAO. If you have an idea for a clever idea for a governance mechanism, just deploy a DAO and see whether it works or not. And see how well it works. So for political scientists, this is a godsend, and already we're seeing, as I said, a lot of political scientists kind of moving in this direction. So it's really, really quite interesting to see. Okay, so now let's go into the privacy. Some of you guys are probably already seeing that there's privacy problems with DAOs, so let's go into the privacy questions. So here I want to tell you one story, and then I'll list kind of the open problems in this area. So the story I want to tell you is, again, maybe a story that many of you have heard about. It's the Constitution DAO story. Again, I think it would be very helpful for me and for the other speakers. Please raise your hand if you've heard of the Constitution DAO story. Okay, not too many. Interesting. Okay, good. That's actually very good to know. So here's the story. So the U.S. has a constitution. Yes, I hope everybody knows that. Right? There are 10 physical copies of the original constitution. Yeah, 10 physical copies. It turns out in 2021, one of those physical copies became available for sale. All right? So what the owner did is what they would normally do with something like this. They went and put it up for auction. They used Sotheby's auction house to put out the Constitution for sale. And lo and behold, there was a DAO that formed. It was called Constitution DAO. It formed in order to buy the Constitution. Yeah, it's kind of cool that a DAO can actually buy a constitution. Their plan was to actually buy it and basically donate it to a museum so that everyone can enjoy it. So this DAO formed in November 21. What's remarkable is they raised $46 million from 20,000 people. What's interesting is 20,000 people from all over the world donated to this, right? I don't know how you would do anything like this. They did this, by the way, within 5 days. Yeah. I don't know how you would do anything like this without a blockchain-like architecture, right? Today, with the traditional financial system, if you want to send funds across borders, it's actually quite complicated. Here, they were able to do it quite quickly. This is a very interesting social experiment where blockchains are actually being used. But unfortunately, they lost to another bidder. So there was a non-DAO, a participant that actually bid 43 million. Remember, they raised 46 million, but they had to reserve $5 million to put it in a museum because the museum had to build a wing for it and so on. So they needed $5 million to protect it after they won it, so they could only bid 41, and this guy bid 43. Now, let me ask you, how did he know to bid 43 million? Yeah, how did he know? Well, this is the problem. The problem is everything on the chain is public, so the bidder knew exactly how much money the Constitution DAO raised, so he knew exactly what it would need to bid in order to outbid the Constitution DAO. Yeah, which immediately raises an interesting problem for cryptographers, which is there a way for a DAO to participate in an auction without everyone knowing what your treasury is? Now, there are two ways to answer this question. There's a mechanism design question, which is to say, how do you run an auction where all the participants are secretive? Yeah, you can't see how much they're going to bid, but one participant is completely open. You can completely read their mind. You can see exactly what their maximum bid is going to be. How do you run a fair auction in that case? And that's a good question for mechanism design folks. But we are cryptographers, so the question to us is, well, can you build a DAO whose treasury will be hidden and not known to the entire world? Yeah, so how do we build a DAO that has a secretive treasury? So let me show you one design. I'd like you to think about this. This is a fantastic question. I'm sure there are lots and lots of designs. Let me show you one simple design. Is the problem clear? Right, there's this DAO contract out there. Everybody that sends funds to it, it's public that they send funds to the DAO. So anyone can just look at the DAO records, the DAO transactions, and see how much funds were sent to the DAO. And yet the DAO wants to keep its treasury secret. How do you do it? It's like I almost need to pause and ask and see if anybody can see how to do it. Anybody has any suggestions? Yeah, please.
Maybe you commit to give a certain amount, that you're going to publish an actual commitment, and maybe there's a penalty if you don't actually end up giving that amount. And then you can maybe create a $0 proof for the sum of the commitment to a certain amount.
Okay, so the problem with that, okay, so that's a good idea. Excellent. I don't know that anybody's built that, and I would encourage you actually to go and think more about the design. That would be fantastic. One issue with that is that when you go and submit your bid to Sotheby's, you have to actually prove that you have the funds. Yeah, and so just a commitment to give funds might not be enough, yeah? And so, and by the way, yeah, okay, so yeah, so there's some issues there, but this is a very interesting direction. I encourage you to think about that. Actually, maybe in the interest of time, I'll show you one particular design, but I'm happy to talk about, this is a really interesting question, so I'm happy to talk more about this offline. But let me show you one particular design that I want to walk through. Very, very simple design. So here's one design. Again, I would encourage you to think of other designs. This is a very large design space. So one design is basically to say, well, let's build an Ethereum contract, an Ethereum application that's not going to manage the treasury for one DAO. It's actually going to manage the treasury for many, many DAOs. And in fact, there are such platforms, like Juicebox is an example of a platform. It's one contract that manages the treasury for many DAOs. And now you see where we're headed in that, all the DAOs' treasuries are going to be commingled together, so you can know the sum of all the treasuries of all the DAOs, but you're not going to know the treasury of one particular DAO, like the Constitution DAO. How do we implement that? Well, so when what the DAO manager will do is when he sets up the DAO, he'll publish, let's just say he'll publish a DAO public key. The DAO public key can be like a pair of points on an elliptic curve, P and Q. Q happens to be alpha times P, and the DAO manager is going to keep the discrete log alpha secret to itself. Okay, so P and Q are now public on the chain, but of course nobody knows, other than the DAO manager, nobody knows what alpha is. Now, when somebody wants to contribute funds to this particular DAO, what the contributor will do is they will send funds to this contract. So everybody sees that funds were actually sent to the contract. Everybody knows exactly how much funds were sent to the contract, but they don't know which contract it was sent to because it's sent using a blinded DAO public key. What's a blinded DAO public key? Basically, we take P and Q and we just randomize them using a random number, right? And you know by the DDH assumption. By the DDH assumption, this pair is indistinguishable from random. As a result, you can't tell which DAO is the recipient of those funds. Yeah, so an observer, all the observer will see is it will see the total assets in the platform, in the overall contract, but it will not see what the particular DAO has raised. And yet, the DAO manager, when he wants to go and submit the bid to Sotheby's, it can actually prove that it has the discrete log, it has the secret alpha for each one of these blinded public keys and prove that these transactions, these submissions actually belong to that particular DAO. Yeah, and then Sotheby's can verify those proofs, and later on, it can claim, using alpha, it can claim those funds and transfer them to Sotheby's. Yeah, so it has the funds, and it can prove that it has them, and the point is that as long as enough DAOs are commingled together on this platform, an observer wouldn't know what the maximum bid is going to be. Yeah, does this make sense? I mean, it's a very simple design. But the only reason I put this up is just to show you there's a huge design space here, and I really encourage you to kind of think of more solutions to this. Yeah?
Just going back to your story about the execution. So you see in 5 days that there were $40 million. That seemed to a general pool that probably conclude that this amount of money belongs to this.
Not necessarily. So the question was whether if you have one DAO that's worth 40 million and all the other DAOs are worth $100, you pretty much know how much that DAO raised. But in general, these platforms, actually these DAOs can be quite large. $40 million DAO is not a very big DAO.
Talk over a short period of 5 days before the transaction, right? I mean, in that, you want to hide the pattern of
that's true.
Giving the money to this thing. So,
yeah, that's true. So maybe there's traffic analysis issues for sure. I totally agree. Come up with more designs. Yeah, please solve it. Yeah, this is a challenge for you. Excellent question. Right, and so, yeah.
We also want to have Sotheby's be on the blockchain as well, so that the data manager couldn't just take the money and go to the Bahamas, right?
That would be okay. Look. So the question was, do we want Sotheby's to be on the blockchain as well, so we don't have to rely on the DAO manager? Now, that of course is the ultimate vision. Sotheby's right now is not on the blockchain. So yes, if we had a famous auction house on the blockchain, they would basically manage all of this, and there would not be a problem. Today, that's just not possible. But in the future, maybe. The only reason, I'm not saying this is the ultimate solution. The only reason I'm bringing this up is just to show you. There's really cool design questions here. So please think of more solutions. Yeah, please.
So in this solution, the user needs to know what's the public key of the DAO.
Yes. Yeah, so the Constitution DAO had a web page, and on that web page, they basically published their public key, and then everybody gets it from there.
If everyone can get the public key, so everyone can link the public key on chain to the Constitution DAO. So.
No, but when somebody sends funds to the Constitution DAO, they send it using a blinded public key. So there's no link between the submission and the actual public key that they got from the web page. Yeah, this is basically under the DDH assumption, this blinded public key doesn't reveal which public key you send funds to. Yeah, it's a good question. Okay, I have to say there are lots and lots of privacy questions in the DAO space. So again, this is a wonderful area to work on. Not only is there political science questions here about governance, there are also cryptographic questions. So one thing that they might want to protect is the list of members of the DAO, right? So how do you become a member of a DAO and then you are permitted to vote, and yet the list of members should be kept private? The size of the membership, the list of members, all that should be kept private. Of course, private voting, an obvious question, right? Can we vote in such a way that we don't know who voted for what, right? So there's a lot of design questions on how to design private voting schemes for DAOs. Private delegation, this is another very interesting question. So remember I told you that if you own a bunch of governance tokens in a DAO, you can delegate those governance tokens to somebody else so they can vote on your behalf. Well, today all that is public. Everybody can see who I delegated my votes to, but maybe you want to do delegation privately. Yeah, so can you build a voting system that would not only support private votes, but would also support private delegation? Yeah, there's a vast literature on voting, on cryptographic voting, but that literature doesn't necessarily look at delegation and such. So again, lots of design questions here that I encourage all of you to look at. And by the way, what makes all of this much, much more complicated is, well, law enforcement has a lot to say about these DAOs, right? And so there are all sorts of laws you can imagine where, maybe we don't want the votes to be fully private. Maybe we don't want the membership to be fully private. Maybe it should be private, but you should be able to prove that the votes, whoever voted yes, didn't vote yes for some illegal proposal, right? Imagine there's a proposal to send funds to, I don't know, someone we don't like, yeah? Pick your choice of who we don't like. Yeah, imagine there's a proposal to send funds to someone we don't like. Maybe you'd like to say that, let's see, so the vote is private, but you should be able to prove that you didn't vote yes for that proposal, right? So proven zero knowledge, you didn't vote yes for that proposal. So there's all sorts of, so compliance with local laws actually make this problem even more complicated. So there's, again, as I said, lots and lots to design here. By the way, I should mention that some DAOs have now, if you're interested, some DAOs have actually even put out proposals for private voting. So they will pay you to develop a private voting system. Yeah, they want private voting, and so they realize the way to get private voting is somebody proposed to pay a developer to develop a private voting system, and then they would all vote on whether that private voting system is what they actually want. Yeah, so you can even apply for funding under these to solve some of these problems. And so the last thing I'll say is, in fact, there are general privacy platforms in the ecosystem, Aztec, Aleo, others. And in fact, some DAOs have actually moved to Aztec. Yeah, there's a big effort to move the voting system into Aztec so that the votes are private, the membership is private, and so on. So that's kind of a big hammer. Using Aztec is great. Aztec is a beautiful, beautiful company. We're going to talk about beautiful system. We're going to talk about that more tomorrow. It's all zero knowledge based. And so there's a big move to move to there. The question that we're asking here is basically, is there a way to satisfy these properties using much, much simpler cryptographic building blocks than kind of generic zero knowledge snarks? Okay, so I think I'm going to stop here. I'll say that there's lots and lots of other hot research topics that we're going to talk about during the day. So let me just quickly go through my list and then I'll stop. Do I have 2 more minutes or how are we on time? 3 minutes, terrific. So that's all I need. Yeah, so one of the issues, of course, that's troubling the blockchain is the scaling problem. Blockchains today are quite slow. Ethereum will process 15 transactions a second. There are faster blockchains, but Ethereum, 15 transactions a second. So how do we scale the blockchain? We're going to talk about that tomorrow. Privacy on the blockchain, as I said. What's interesting is that unless the blockchain provides some level of privacy, businesses simply cannot use that mechanism at all. For example, if the university decided to pay my salary in crypto, in ethers, for example, today everybody will see exactly what my salary is. Yeah, and so similarly, yeah, well, anyhow, so there's definitely a need for privacy on the blockchain and businesses, so that businesses can actually use it. How do we do that? Interoperability between blockchains is a very interesting question. I want to make sure this is on everybody's top of mind. Interoperability is a big question, is kind of a big issue these days. Let me explain what the interoperability problem is in one sentence. So effectively, there are lots of blockchains out there. If everybody was running on Ethereum, everything would be nice and rosy, but there are actually lots of blockchains out there. And the problem is, imagine there's a guy here, Bob, on the Cosmos blockchain that owns some NFT, and imagine there's a marketplace on Solana. Magic Eden is a big marketplace on Solana, and now Bob is asking, well, I'm over here, and I want to use the marketplace over there. How do I use my NFT? How do I move my NFT from one blockchain to another? This is, again, a wonderful technical, very difficult technical question, and so again, this is something that we'll talk about later on in the course. So it can be done, but it's actually not easy at all. And so the last thing I'll say is, okay, MEV, I guess we'll talk about in day 4. The last thing I'll say is there's also a lot of interest in what are called zero-knowledge proofs of solvency. Unfortunately, there have been some recent events of certain exchanges that will not be named that were supposed to be solvent, but were not solvent. So, well, in the real world, the way we solve solvency is we bring an auditor to verify that the bank is solvent, right? So that's an expensive operation. You have to trust the auditor to do things correctly. In the world of blockchains, we can do better. Yeah, we can actually use zero-knowledge proofs and the fact that all the data is available on-chain to actually prove in zero-knowledge that an exchange is solvent. So there's a big area there, and of course, there's a lot of interest in that given recent events. Okay, so that's what I wanted to say. I think I will stop here, and I'm happy to take any questions, or we can take a break and wait for Lara's talk. So thank you very much.